Continuing where we left off, we had the variation parameters formula, simplified it as much as we could, and now we're to y particular equals some integrals we have to evaluate pretty much. All right, first thing is we want to be able to evaluate these integrals. So we're going to exchange some of these terms. Actually, we went from cosine 2x and sine 2x just to sines and cosines of just x. Now we actually have to go backwards again to make things easier to integrate to 2x's. Let's go ahead and do that. So this is negative cosine of 2x. We've got the integral. So sine squared of x dx, that's hard to integrate, but going back to your integration class, it's easier to take the sine squared from here, and we're going to rearrange this identity with the cosine 2x to get rid of the sine squared and exchange it for cosine 2x. So taking that one, this ends up being, so if I move the 2 sine squared of x over, add it to both sides, I subtract the cosine 2x from both sides, divide by 2, we end up with sine squared of x is equal to 1 minus cosine 2x over 2. Or you could have taken it from a table of trig identities. But here we go. That one's a lot easier to integrate than sine squared of x. So I'm going to exchange the sine squared of x with 1 minus cosine 2x over 2. I am going to distribute the 2 between each one to make it easier to integrate. So that's actually 1/2 minus 1/2 cosine 2x dx, then plus sine of 2x over 2. And so in here I can actually do, well, here I'll rewrite it. So this is negative tangent of x, and then this one I can actually rewrite as sine 2x. So this is actually exactly sine 2x right here. 2 sine x cosine x is sine 2x. So I'm going to just have a plus sine 2x. And all that is dx. All right, well, now if we integrate, it looks a little bit easier, except for that tangent, but I just note that one. So here we have negative cosine of 2x. Okay, the integral of 1/2 is 1/2 x. And I've got minus, so let's do this. Cosine 2x antiderivative is going to be something like sine 2x. But then with the chain rule popping out of 2, I have to take care of that, so it ends up being negative 1/4 to get it to all work out. And then plus c1. And then I have plus sine of 2x over 2. The integral of negative tangent is actually the natural log absolute value of cosine of x. You could have looked that up in a table, but also if you look at this, all right, if you take the derivative of natural log absolute value cosine x, that's going to put the cosine x on the bottom of the fraction. Then on the top of the fraction, you take the derivative of the cosine x, that ends up being negative sine. So yeah, this is actually the antiderivative of negative tangent. And the last bit we have is plus sine 2x. Well, okay, so that's going to turn into a cosine 2x overall. But then we have to worry about a negative and also a half from the chain rule. And then plus c1 if we're being careful. Okay, so this looks plus c2. So now we'd actually like to trim this down to as little as possible because there's probably some extra stuff in here we don't need. First thing, let's see. So we have equals, I have negative 1/2 x cosine 2x. That looks fairly unique among all the terms. But I also have negative times negative, so plus 1/4. What is that? Cosine of 2x sine 2x. And I have my plus minus c1. This is y1, so I'm just going to write it as c1 y1. We're going to end up dropping these terms. Then I have my plus sine 2x over 2 times natural log there, so plus, let's see here, 1/2 sine of 2x times natural log absolute value cosine of x. And then I have minus 1/4. I have my 1/2 and my 1/2, and then I have sine and cosine, so it ends up being cosine 2x sine 2x. And then I also have, let's see, 1/2 c2, and then the sine of 2x was actually the y2 solution, so I'm just going to write that as y2. So now looking at these, we can actually cancel some stuff. So the first thing is these actually cancel, right? Positive 1/4, negative 1/4. We don't really want to have the homogeneous solutions inside of the particular solution, so we're actually going to get rid of those as well, this minus c1y1 and this plus 1/2 c2y2. And then from there, the only thing that's left is kind of the more unique stuff here. We ended up with a negative 1/2 x cosine 2x and a plus 1/2 sine, and I'll just put y particular, sine 2x, natural log, absolute value cosine of x. And there we have it. That's our particular solution, and it's probably as simple as we can possibly make it.